APIT.
Okay. Shall we start, or we shall wait for 5 minutes? Okay, so I got my sensor working and my Node MCU working. Now it is taking up a sensor and the reading. So you can see now the inside room temperature is 30 degrees Celsius and humidity is 37. So this is how web look like. So again I'll repeat, maybe there is network connection gap. So I got my sensor and Node MCU running. So this is what the page is looks like. So this page is hard coded into a code which we are uploading on a Node MCU. Instead of hard coding it, we can use different IO services, like we can use ThingSpeak, but ThingSpeak will not give us a graphical representation of our data, only the chart, pie graph, those chart documented data it is giving. So instead of that, we can use Adafruit IO or AWS IoT or Azure IoT. So on that, we can create a beautiful IoT dashboard where we can integrate our different sensors. Like in the environmental sensors, we can have lot of things like temperature, humidity, then carbon dioxide or the pollutant level, and lot of things are there. So we can create a very good dashboard and the UI and UX, and we can display our data onto it. Furthermore, we can use these cloud storages or cloud orchestrators or middlewares to capture our data and store it on the storage area, where we can use that data as a data set, and then furthermore we can feed that data set on our machine learning model. So for example, if we have created a pulse oximeter device, and that entire information what that pulse oximeter is collecting from a patient's body, that is stored on the record data set, then it can be forwarded for a further analysis to check whether that person will have some kind of a disease based on that data. Maybe that data is a wavelength data, that data is a graphical data, that data is a statistical data. So depending upon what type of model and what type of input method we are using, forward feed, back propagation, linear feeding, so whatever the method we are using, depending upon that we can tune our data set and we can have a machine learning model and the approach to define further prediction. Furthermore, if we can take an example, like if we can collect data from health system, like the ICU health system. So there are various instruments. I'm not the medical person, so I'm not able to take out the names of those instruments. But some are like blood pressure, ECG, then that big display which is besides that bed and having some wires. I don't know what that name is, but still that device can be connected to a network, and a lot of devices are getting connected. So recently I visited hospital for my routine checkup. That time I saw various devices which are connected to the network, and all doctors and nurses are taking their inputs or whatever the data that devices are collecting from their own servers. So they have their application developed, and through that they are collecting that information. Even doctors are writing their reports, or even MRI reports, CT scan reports, those are all available online. So we can collect every data which is permitted to us, and we can create a data set, and by that we can flow that data set into machine learning for further prediction. So their IoT can help us more, and we can have a health monitoring system properly installed. Even when we are try to create a variable device, we'll try to create in our session only. We'll try for that variable device which can check for our blood oxygen level, blood pressure, and all the basic things what we can collect right now from whatever the sensors we are having with us. So we can create that variable device. We'll put as we are having displays. So we are having three types of a display. One is 1.3-inch display, second is a 0.96 inch, and third one is 0.96, but the rectangular display. So we can use one of the display, and we can create a variable device which can collect a lot of information about that person. And even we'll try to implement some vibration sensor or tint sensor into it, so we can detect some other activities as well. And all these things we will be putting it on a server, like the web page we are seeing right now, as it is constantly giving me a temperature of 30 degrees Celsius. If I refresh this again, though it is giving me a constant result, and I am in a private mode. So once I'm refreshing it, it is taking up a new session, and this temperature sensor can be accessible. So if I wanted to show this on a public network, because right now it is on internal network, so I can pour forward my router with my public IP address, and by my public IP address you all can see on your browser by putting up that IP address what exactly this result is. Or I can use NGROC service to capture this IP address and map this IP address with my public IP address. That also possible. NGROC service. Right. So this was the one. Now we are almost familiar with how to interface sensors modules with the wired network, means the node MCU, and with the wireless development board as well. So let's talk about something interesting and something related with the security, because when we are dealing with this kind of a data, this data can be a credentials as well. So once we are dealing with this kind of a data, information security or cyber security has to be keep in mind. So let's throw some light on that, and I'll demonstrate you some security application which we can use. Generally, a penetration testing application which we can use and we can create with the Node MCU. So firstly, I'll just show you this one. So in IoT or the Internet of Thing devices, we are having these general devices. I'm purposefully taking up with the very general examples of IoT devices. This can be a very specific, like in automotive, we are having robotic arms, we are having conveyor belts, in product food and safety, or the food production department, we are having bottle filling plants, we are having what we can say, food preparation plants. So there are a lot of things if we dig down into the industry. So all these devices or these plants are now online, and because of this online nature, there are some security flaws or security questions which are coming up. So for example, if we can take a smart TV, then these smart TVs are equipped with a lot of other things like internet, camera, and all that we already discussed. So what kind of information these smart TVs are collecting? Smart TVs are collecting information like passwords, email, financial data, sounds, video recording, means AV, audio and video, search histories, and a lot more things. As the smart TVs, what we are seeing right now, are backed with very popular framework Android, or some are having their own proprietary Android applications in it. But still, they are collecting this information, as we can use smart TV as our general computers. Even through Raspberry Pi, which we just saw yesterday, there also I can create a smart TV, and through that I can collect all the information. So this is a very awkward and very dangerous situation where we are dealing with this such kind of a data. Then talking about the healthcare devices, if we are having a variable device, then what kind of a data that variable device can be stored, and if that variable device is hijacked or hacked by some another way, because again that variable device is getting connected to a network via Wi-Fi or Bluetooth. Even if we don't have a Wi-Fi and Bluetooth, we are having just a hardware, there is a hacking method called hardware overclocking. So through hardware overclocking also, it is a very dangerous for what we can say, for a data perspective. Now through a healthcare devices or just a variable device, that variable device can record individuals heartbeat, then the pattern of heartbeat, then sleep pattern, a walk pattern, how you sprint, how you run, all the patterns are captured. So by this pattern we can judge what kind of person you are. You are a healthy person, you are a thinner person, you are a okay person, you are a fit, you are not fit. All these things, what is oxygen saturation in your body, what is the oxygen saturation peak ratio, at what time it is on the peak, it is 100%, 101%, and what time it is lower if you are having any certain diseases. And because of that we can identify what kind of disease you are having, maybe a blood pressure, heart related problem. So all these kind of a data at that variable device is storing. On top of that, wearable devices are funky nowadays. So if we search on internet wearable devices, you can see cool designs and internet enabled devices. So you can use internet, putting a SIM card, 4G variable bands or 4G watches we can see. So by because of that reach network connectivity, live location can be hijacked and a person can be kidnapped, or maybe anything can happen with that person. Then through that your user activity is also monitored. Then if we see the routers or the network instruments what we are using for routing information, even a node MCU, then that routing instrument or a router is responsible to carry entire network and the entire network communication. Now because it's a nature of that device, it is carrying the entire network communication. Now that becomes a very vulnerable sometimes. Now how it is vulnerable? Because of not updating that device properly, or not having a proper security layers or security protocols configured. Sometimes we are having a habit, like when we purchase something, we are keeping it on a default mode just to see how it's function. Now that is a very dangerous situation. So by having these default passwords and all, attacker can gain access of your networking device, that self, and attacker can listen all the traffic what is flowing through that. And if attacker is accessible to that all the traffic, then attacker can guess out what kind of password you are having for a particular banking, or for a net banking or something, and even your all the credentials can be hijacked. Then the most importantly, there is a crease, like we can have Alexa or okay Google. Now virtual assistants or voice assistants are very good in terms of when we are driving or when we are riding a bike or we are busy in something, and then these assistants are helping us to find a way, helping us to find a recipe, will helping us to find any problem for our problem statement or the code or something. So it is very beneficial in that case. But this is a brighter side of these instruments. Now, the darker side of this instrument is these instruments are actually getting into your life. Means what? These instruments are connecting on the network. Then you need to allow that instrument to search for the search history, what you have searched so far, in order to improve its performance. Like, for example, if you are using Google Maps more and more, and how you are using and which terrain you are using, depending upon that your map is getting adjusted with the user settings. So I personally observed this. So in my phone, in my Apple phone, I'm using iOS deliberately, as it is having a better security than the Android. That's why I'm using it. So on my iPhone, I'm having a Google Map, and I prefer Google Map over the iMap, because iMap is sometime it is very disturbing, but Google Map is good. So on the good map, on the Google Map, sorry, on the Google Map, I use map frequently because I travel a lot. So that's why I'm having a habit of using Google Map instead of asking someone like where to go and how to go. So depending upon my searches, depending upon my use, depending upon in which area I'm turning on my map and the location, and in which area I'm turning it off, what is the terrain? It is a city area, it is a hilly area, it is a some other station, or it is having a low bandwidth station, low network. So depending upon that, it is adjusted to my use. And suddenly, when I asked my wife to navigate me through map on her phone, so she was confused, like her map is not providing a result as my map is giving. Why? Because she don't use map that frequently, because she's with me for traveling. So that's why I we shared my map only. So that's why that map is not having habit to search the thing. That's why it is updated, but it is not updated on the user profile. So it means what? These instruments are getting into your life and getting all these data out. And if you see that the financial data, if the Alexa is connected to your network, then financial data is getting flowed through the network, and that can be accessed through Alexa. That's why Alexa or okay Google or any voice assistant is giving you okay Amaya, you received blah 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 funds in your HDFC bank, in your Bank of India bank, in Maharashtra bank, and all. So so depending upon that, because that okay Google, that the voice assistants, or Alexa what we are having at home, so that is configured on the email, and that email is received email from my bank that so and so money is deposited credited into your account. That time that instrument louded it out. So that means that it is also considered with the financial account. Now the example, like it is actually collecting emails, but as it is collecting an email, when you are surfing on a network, then it is a possibility that it can store the cookies from your net banking sites, and maybe fraudsters can achieve it, and maybe anything can be happen, because uh, information security or hacking or pen testing, the pen testing is what, it is not good that I self call myself as a hacker. So instead of that, I'm providing a security services. So that's why I used to use a word penetration tester. So penetration testing is a method which involves real time hacking to test whether my particular instrument or my application is vulnerable for any kind of attack or not. If it is, then I can patch it. So that is the lawful activity. That is the penetration testing. because you put ethical before hacking or after hacking. Hacking is the hacking, so it is a criminal activity. So by this, then even you can have a internet enabled car, the mg hector internet inside. So I'm not doubting on the mg hector security. I'm not the person who can blame mg hector security, or I don't want to blame it any kind of. I'm just taking it in a general sense, not in India but outside India, which are where the network enabled cars are available. Means the car cpu is so intelligent it can navigate itself, not the Tesla is way beyond that. Not the Tesla, but the other things. So in some foreign countries they are having their cpus. In India also the cpus are now getting intelligent. Like you can have anti braking system, you can have what we can say, speed locking system. Then we can have auto drive settings. So there are lot of settings, and even we can get a lot of information about our cpu on the app, the app what we can have through that car manufacturer. So these are network enabled cpus, taking all the information related to that car, putting it on a server. And if I'm a attacker, and if I get that information, then I can control the entire car. Then of course there is a cctv which is connected to network. So by cctv is also a iot device, so through that also events can be captured. So these are the actual devices which we see around us. And this can emit this kind of information to attacker, and attacker can use this information for their own good and purposes. So the main thing telling you all these things is it is not that easy to hack into a router. Yes, because that router is also having a good firmware, the router is also having a good encryption mechanism, it is also having a good what we can say, password locking mechanism, then the security, layered security, non-layered security, device level security, access control. Lot of things are there, though attackers are managing to capture data by hacking into the Wi-Fi. How? Nowadays, because of the Node MCU and the feature of the Node MCU, that Node MCU can be in access point mode and can be in station mode, both the mode. Node MCU is a most favorite and trusted device to create Wi-Fi jammer or Wi-Fi extruder or Wi-Fi hacker. Now, what all these three are? Wi-Fi jammer, what Wi-Fi jammer will do? It will create a rogue access point hiding the actual access point. Means what? I can turn my node MCU into a Wi-Fi rogue access point. So here, if you can see RX100 5G and RX100 and even Alcatel, which is another node MCU. So these three are the legitimate Wi-Fi connections through the router, and one is from node MCU. So if I create a Wi-Fi jammer, then I can select one of these, or I can select all three, and I can flood the SSIDs. So I can create 100 or thousands of SSIDs in the one go, and all are flooded on a network, hiding my original SSID. Now someone says that these rogue access points are not having a secured mark here, or it is an open one. No, that is not. Let me show you. Now I'm taking up one of the node MCU. So there is no requirement for video to see, because I'm not attaching any sensor or any module to it. I'm just taking up a node MCU. I'm going to my code, because I have to what we can say, I have to flash my node MCU. So I'm having a node MCU jammer over here. So what I'll be doing is I'll be flashing its memory. So whatever the base bootloader it is having, bootloader is means what? For example, in a very layman term, we can say operating system of a node MCU. So I'll be flashing it out. Means I'll be formatting its original operating system, and I'll be putting up with the another operating system. So that is called as a flashing. So I wanted to flash it. So I'm having a node flasher over here. Is my screen visible to all?
Yes, sir.
Okay, great. So here is a flasher. So I'm running on a 64-bit operating system. Here is a node ESP8266 flasher. This is a reprogrammer. Now here it will select a COM port. You can select a COM port if you're having many node MCUs connected, 4, 3, 5. So here on only one, so I'll select a COM 4. Then I need to go to a configuration and I need to select which file I wanted to upload, right? So here it is. I'll be using a code deauthor. So deauthor is a de-authentication. So de-authentication means what? In networking, there are stacks like TCP stack, FDP stack, not the FDP stack, UDP stack. Sorry, TCP stack, UDP stack, ICMP stack, and depending upon the stacks, the communication is happening. So in any stack, if a de-authentication is fired by either way, it is from a server or it is from a client, that whole connection needs to be resetted and everything has to be reconnected. That is the de-authentication. That's why I'll be uploading a de-authenticator or de-authentication firmware inside my node MCU in order to create Wi-Fi jammer. So for that, I'm having the 2.5 RC and 1 MB bin. So I have already selected it. The author 1 MB bin I've selected. Once I can add so many paths to it, but if I'm having other what we can say node MCU, so I can configure it from here. Then at the advanced baud rate will be 230400. It is a communication rate between my node MCU and my USB and my CPU on my computer. Then the flash size is 4 megabytes because it is having 15 megabytes of a flash memory. So that is the one. And flash speed is 80 megahertz, so which is a moderate one, which is the maximum one, not the moderate. It is a maximum one. And 4 byte, which is a moderate one. It is not too low and not too high. And the SPM mode needs to be DIO. I'll be explaining QIO, DIO, QOT, DOT when we are seeing the protocols. Maybe day after tomorrow, we will be seeing some protocols, IoT protocols, MQTT, known as OIS. That time I'll be explaining what exactly DIO is. Then I need to, once everything is selected, COM is selected, configuration file is selected, advanced setting is done. Then on the operation side, I'll be clicking on flash. Once I click on the flash, it is waiting for the access point MAC. That is what the access point mode. Once it is in access point mode, this will be the MAC. And when it is in station mode, that is STA mode, the node MCU, that time this will be the MAC. So both MACs are different. MAC ID is what? Media access controller, which is a base identity, which is a base identity of your device. Yes. Is there any question? Okay, it will take a bit. Now, this program is not written by me. I have borrowed this program through GitHub. The GitHub repository called dauthor, ESP8266 dauthor, and I'm giving a full credit to that developer for developing this such good penetration testing activity, as this is very good when we are testing out for the different types of ESP node as well. So if you are having ESP node, if you are having WLAN node, if you are having any WSN node, that is wireless network sensing technology node, though it is fantastic activity to perform pen test, and we can see how that device is reacting. If that device multiplies the connection, it means what? It is vulnerable for different types of flooding attack, and that can be a DOS, that denial of service attack. Yes, now my node MCU is ready. Now it's supposed to reset for first time, so I'll be plugging out my power source and plugging it again. I'm not pressing a reset button over here, because reset button is also doing the same, disturbing a power supply and reconnecting it back, disconnecting and reconnecting it back. But it will not solve the purpose over here, because we need to hard reset it. Means we need to completely turn off it. Once we are clicking on the clicking on the reset button, some amount of current is still flowing to activate that reset button. So we don't want to do that. Now here at the point, you can see one more Wi-Fi network is created, that is called pond. So pond is a network connection, which is a result of the deauthor program, which is programmed here. And once it is connected, it will give us a default IP address 192.168.1.4. We need to navigate ourselves to that. I'll just take it out. If it is not connecting, then I need to forget the connection first. Okay, so what I'll do is I'll forget the connection and I'll research it. I'm purposefully not connecting any other device to my Wi-Fi card, because this is the inbuilt or onboard card what I'm having, where we are connected, and this is the Wi-Fi 2, which is a USB one. So all the experiments are going on to the USB port. Okay, something wrong. Yeah, now it is asking me for a password. Password is D author. You can change password and SSID later. Yes, we wanted to share the connection. If we are not sharing it, then the rogue access point will not get activated. So it will take a bit. Yes, it is already connected, I think. So let's navigate on 192.168.1.4. Let's see whether we can see opening page, and if we are not seeing it, means that it is not connected. See it again. This time I'll say no. Let's see. I'll just disconnect my USB and my Node MCU both, and I'll plug into it again, and Node MCU again. The visual sign on the Node MCU once the network is connected is it will flash a blue LED continuously. So that is the indication there is a network, or there is a machine which is connected. Uh, don't know why it is happening like this. Maybe what I'll do is I'll connect to the RX100 first here with my USB, and then I'll connect it with my Untitled Chapter. Okay, sorry, I got disconnected because of my network was resetted. Okay, now I'll share my screen. Now here the connection is connected. Now it is giving us a warning that you will be not using this to jam any production Wi-Fi network. We are not responsible for it. Okay, so we understood the notice. We click on understood. Now here this is beautiful dashboard. Now here we can scan for the access point. So once we click on scan, NodeMCU will start scanning it, and now it have detected these are the three access points which are available. Now I can choose any of this. So I'll choose RX100 for flooding. So I'll select the RX100. Then I need to get into the attacks. Now on the attack, I can clone the access point. So I'll click on the clone, and then I'll click on deauth. Once I click on the deauth, my attack is enabled and it is starting deauthentication. Then I can have a probe request started, and I can enable this. Even I'll stop it right now. Even on the SSID, I can add any SSID over here. So if you can see over here, these are the probe requests. So I'll clone this. I'll add the same SSID, that is RX100. Clone numbers would be 199, that is almost 200, and it needs to be encrypted. If we are not clicking it encrypted, otherwise it will not show the secured mark. It will show open mark, so anyone can suspect that this is a suspected network, and we should not connect to it. Now if you can see, all the points are flooded now. These are the access points. If we see over here, it will take a bit to load. It has already started. Just a moment, it is having something going wrong. It will clone, and it has started. It is not showing here, but in the background, it have already started flooding the network. So once anybody wanted to connect with it, that legitimate user will not able to connect as. Okay, error loading. I'll clone it. We'll have RX100 about 200. Add this. and we'll see. Now you can see one RX100 has been added. Like that, other RX100 will also be added. It will take a bit to load, as I am using a very low powered cable. It will take some time as it is having only 480 kbps. Two RX100s are merged. These are the different access points. It will take a bit to flood the access point. So here we have successfully flooded the access point, and we can create a deauthor on them. So this is the one way to create deauthentication pages. Even on the station mode, you can have various stations. Then I can do the probe request with RX100 as a it is going up 48 by 48, and I can clone. It is not resolving the SSID, maybe uh, as I'm experimenting this deauthor a lot of time on the same MCU, not MCU. So maybe it is having a VRICT RAM, or not the RAM, sorry, VRICT flash memory. So that's why it is not holding up what the instructions is given to it. So this is the one way to create a jammer. Now the another way is if there are some Wi-Fi networks available, and nowadays the Wi-Fi networks are like you need to give your username and password, and then only you will be able to surf on the network. And to get that username and password, you need to sign it up, and once you sign it up, the OTP is coming. So if I wanted to hijack that, that also I can do. If I wanted to hijack it, uh, how I can hijack it, I can create a captive portal. So I can design a captive portal which looks like the same. Like for example, if you are visiting near to a railway station, then the Railtel free Wi-Fi is there. So once you click on that free Wi-Fi setting, then it will ask you to log in, and once your credentials are accepted, then only you will be able to log in into then you will be able to serve on the network. So similarly, we can create that kind of a rogue access point, fake access point, and we can force our user to log in into that. And once user is logging into with its correct username and password, or sometime user is connected to a Wi-Fi, and then it asks you for updating it and provide your Wi-Fi key. Once you provide that Wi-Fi key, then automatically that Wi-Fi key is captured on a node MCU, and then user will be forwarded for a validation. So that is called a captive portal that we can flash. So I'll be using a same node MCU here, same node MCU. I'll be having a captive portal. Here is a normal Arduino code for a captive portal. And here our node MCU will be in access point mode. I'll select node MCU version 1, and then port 4. I'll upload it. So here SSID is AMEA Office Network, which will be flashed. Here we will be getting connected to it. And once we are getting connected to it, it will ask us to provide information about your router, and then the router will get update. So router's password, Wi-Fi password. And it's still compiling it. I don't know why it is taking that long. Maybe I need to disconnect this on the network first. It is almost 35-42%. It is done. I'll just press reset. Now we can see here on the page AMEA Office Network. Once I click on this, now I have already connected with a regular network, so it will not directly going to open a network login page. But yes, it have detected it. Let's see. Now it has detected it, and here it is requiring my Wi-Fi password for updating. So if we trick a user and user is providing actual Wi-Fi password, and once it is what we can say uploaded, it is showing information like updating a page. And if I wanted to see the same password, then I can give creds. I can have Ameya Tambe as a password. I can see that password in pass. The pass is a directory. So first time I have logged in through ametambe at the rate, and the second time I have logged in through ametambe. So these information or this password is already stored in Node MCU until unless this Node MCU is powered on. So once the power is gone like this, the entire captive portal is gone now, and no one can connect with this. So this is a very handy in the case of your just moving around and you wanted to trick persons. Then you can use a 9-volt alkaline battery to power a Node MCU. Once you power this up, that's only you need, and you can put it into a pocket and just roam around on the area. Now just going around in the area in the situation is not advisable, but once a situation is well enough, then you can try it out. So so this way we can have a pen test on small WSN networks or on the Wi-Fi enabled networks. So I think this is for the day. We are open for question and answers. If we are having any question answers, please do ask. Where it is? My section. Yeah.
Hello, sir.
Yes, sir.
My name is Darshan Roykar. Actually, this is very informative sessions. Whatever we are learning from you, it is really informative. But being a layman, actually, I don't know what is IoT. And
Okay.
directly you start implementing. Would it be possible for you to show how to code line by line by using one sensor and Arduino Uno board?
Okay, so how to write the code? You wanted to see how exactly code is written and what are the different variables of it, and how the structure is of.
Yes, yes,
Okay,
yes, yes, yes.
yeah, it is possible.
What are the basic function? What are their syntaxes? If I want to connect one particular LED and if I want to on and off, then what shall I do?
Sure, sure, sure. I can do that. What we'll do is we'll take up example code right away. So this is the
Thank you, sir.
Arduino sketch. Now what I'm doing is I'm taking up a one example which is having the LED blinking code that is just in here. This is the blink code. Okay. So here, this is a very simple code. Here is a void setup. So this is what this entire code is in C. So if you know C programming, then it is very easy to understand. So this is the first setup. In a C, we are used to write void int or int main void main or int main. So similarly, here is a setup. So setup is a main function of entire body of a Arduino code. Then we will be having a pin mode as a variable. Now what is a pin mode as a variable? This variable will capture the equations, or it will capture the link. So if it is a pin mode, and pin means the connection pin, if I'm having node MCU right now, so D1 is what the pin is. Now the D1 spin mode is what, once I connect this with my LED, that is the LED button, like we are having, this is the LED button. So once we are having a pin mode as a LED button, and it needs to be a output. So once the button is pressed, that LED should be blinked, so that is the output. Now this needs to be repetitively happened, so for that we are putting it into a loop. So here it is a loop. So for displaying any information, we are using digital write. So digital write is for displaying any of the action. So what I'm displaying? I'm displaying the LED button, which is a high, means which is a turned on. High is representing turned on, state on, and low is representing turn off the statement, means the connection is terminated. So and this is into a loop. Once the digital write is high for 1000 milliseconds, so delay is there, so the light will turn on. It will wait for a 1000 seconds, and after that it will turn off. It will wait again 1000 milliseconds, and again this situation is repeated. It will turn on for a 1000 millisecond, it will turn off for a 1000 millisecond. So if I can get my Arduino board over here, and I'll run this code inside it. So here it is. I'll be interfacing my LED. Even I'm having a LED over here. So here it is the LED pin, which is not defined. So it can work with the LED which is here. So L panel which is here. So if I flash this, I select Arduino Uno, COM14, and then I'll upload it. Now it is done. Now if you can see over here that LED state is turning on, waiting for a milliseconds, and again turning it off, on off. So this is a simple blink code. Now what I'll be doing is I'll be snipping up with the small sketches, and that sketches I'll be taking up for the tomorrow's first session. So those are very new to the IoT. They will understand how to write the code. Even I'll share some links, some videos which are demonstrating how to write a code. So if you're having a hardware with you, then you can do it on the hardware with me, or else you can use Tinkercad to do the simulation. So on tomorrow's first half, what we'll do is we'll go with the all the loops, variables, and strings, which makes this sketch, and how we can write the different sketches for moving the different objects or the elements. Okay.
Okay, sir. Now, in each Arduino program, do we have that loop function?
Yes, each Arduino program you have one setup and one loop, because that sensor has to be operated in a continuous manner. So if you are not applying any loop, then what will happen is LED will blink once and it will wait. That's it. That functionality is over. But you need to have it repetitively, or else in
Okay.
DHT11 you need to continuously monitor your temperature. So if I'm not using a loop function, then what will happen is it will monitor a temperature for a once, it will display it, and it will stop monitoring. That is totally depending upon your logic.
Yes, sir. Okay.
Even I can share some codes. I was having that in mind to share with you all guys. So this is an official Arduino tutorial where the each and every variable, what it does, then how exactly this loop is considered and why the loop is required, everything is written perfectly. So you can go through with this. Even I'll be taking up a one session tomorrow, maybe a 1 hour on the session, so where we can see how we can code the things. Yes.
Thank you, sir.
Yeah, any other questions? Yes,
Hello,
ma'am.
sir. Uh, in last day examination, what type of questions will be there?
MCQs. Yeah,
MCQs. Okay, based
based
on
on
whatever
whatever
you.
we have seen.
Okay. Okay, sir. Thank
Okay.
you.
Okay, so I guess there are no questions. So thank you very much for listening me. And if you are having any further questions, do post on a WhatsApp group. I'll definitely answer them. And definitely on the tomorrow first session, we'll take basic session one, and then we'll start with the other agenda. Okay. So thank you once again. We'll meet tomorrow.